Does it move or not?
Yes.
It will move. And when we push the object, it will move towards the point of contact or away from the point of contact?
Away from the
Yes, it will move away from the point of contact. Next, can you see one object?
Table.
Yes, table. Here we have a table. I am going to move this table like this. What I have done here?
Pull.
Yes, I pull this object. Does it move or not?
Yes.
Yes, it moves. So it moves towards the point of contact or away from the point of contact?
Towards
the point of contact. Yes, it moves towards the point of contact. Next, can you see another object?
Eraser.
Eraser. Is it pushing or pulling?
Push.
Yes, we push the eraser. Then does it move?
Yes.
Yes, obviously it will move. Does it move towards the point of contact or away from the point of contact?
Away.
It will move away from the point of contact. So from this example, we can understand that the motion imparted by an object is called a force. Motion imparted by an object is called a force. Because whenever we are pushing or pulling an object, there will be a motion occur. Okay, so we can define the force as push or pull on an object is called a force. Let us see a video that. What is the type of force applied here?
Push.
Push or pull?
Push.
Let us check.
Well done.
Yes.
The player is applying a force on the ball. The force applied is a push.
Yes. What is the type of force applied here?
Push.
Push. Let us check the answer.
Well done.
Yes.
The boy is
Done.
applying a force on the balloon. The force applied is a push.
Here what we done? Push or pull?
Push.
What?
Push.
Pull.
Push.
Let us check.
Not really.
No, it is
The
wrong.
player is applying a force on the
The
moving
answer
ball.
is push.
The force
They are
applied
pushing the
is a
ball.
push.
Here? Okay. Then the force can exert a motion, I said. How it is changing the object's position and state of rest and shape, size, etc. Can you give an example? Do you like football now? So in a football, penalty kick is done. Before starting the penalty kick, the ball will be at the rest position. Then what they will do? The player will kick the ball. So he
Force. Force is defined as a push or a pull. It is the external agent that acts on an object and causes it to move. An object will continue to be at rest unless an external force, such as a push with the hand, is applied. This will change the state of rest into state of motion. Force can bring about changes in the state of an object. Let's place a baseball on a table. It is now stationary. If we push the ball a little bit, it will roll forward slowly. If we push the ball harder, we are applying greater force. More force will make the ball roll much further. We can say that the force can set a stationary object into motion. Let's consider another situation. Our baseball that is on the table is now rolling. If we place our hand in front of it, the ball will stop. Here, we are pushing against the motion of the object in order to stop it, meaning force can stop an object already in motion. Now, let's start the ball rolling again. If we place the cover of a notebook at a slight angle in the path of the rolling ball, the ball's direction will change and it will roll away from our notebook. From this, we see that force can change the direction of a moving object. Summary. Force is a push or a pull which changes the state of the body. Force can set a stationary object in motion or halt a moving object. Force can change the direction of a moving object or stationary object.
Is it clear?
Yes, ma'am.
Okay. Then we have to learn that how we are applying force on this object. So let us see. We are applying force on the object as two ways. One is balanced force, another one is unbalanced force. So let us see. One is balanced, other one is unbalanced force. Balanced and unbalanced force. How we are applying balanced and unbalanced force on an object? Here we have a table. Suppose two persons are standing near to these two sides. How they are applying force here? If they are pulling each other, this table, if they are pulling each other means, if they are applying equal force on this object means, does it move or not?
No.
It will not move. So that kind of force is called balanced force. And suppose the one person acting more force on this object, this person is acting with less force on this object means, in which direction the object will move?
In the body.
Yes, where the high force acting, that direction it will move. So if they are acting high force on this direction means, it will move this direction. Is it? So that type of force is called unbalanced force. So did you learn the tug of war? Do you know the tug of war?
Yes, ma'am.
See, this is the tug of war. In this competition, two teams will be there. This is A team, this is B team. So if they are applying equal force, what do you mean by and here? The unit of force. Yes, unit of force is Newton. So if they are applying equal force on each other means, does this object will move? No, it will not move. And here you can see, here this team is applying 300 Newton and this person is applying 100 Newton here. What is mean? What is meaning here? Which means this person or this team is applying more force and this person is applying less force. So obviously it will move in the direction of more applied force. This is the balanced and unbalanced force. This is an example for balanced and unbalanced force. Then we have to learn about the types of force. The types of force. What are the types of force? Do you know?
Contact.
Yes. There are frictional force. Force acting opposite to the direction of motion. Force acting opposite to the direction of motion is called frictional force. This is considered this is a surface. This is an object and we are using another object in the like this. In each object there will be a surface. So suppose I am sliding this object B like this. What happened? How the frictional force will act on here? Opposite direction. That means whenever this object slides over the surface of this surface will act an opposite force on this object. That type of force, that kind of opposite force we call it as frictional force. Next one is non-contact force. Non-contact force means without any interaction. The force is exerting without any interaction. That type of force is called non-contact force. Here you can see force experienced by bodies even if they are not in physical contact with each other. That type of force is called non-contact force. Here are the examples. One is magnetic force, electrostatic force and gravitational force. Magnetic force. This is a magnet. This is a magnet. What are the properties of magnets? Yes, a magnet contains two poles. One is north pole and another one is south pole. And like poles will repel each other. Unlike poles will attract each other. That is the property of a magnet. So this is a metal or iron content object. So does it attract or not? Yes, by magnetic force it will attract each other. Understood? So this kind of force is called magnetic force. This is a non-contact force. Clear? So here you can see force exerted by magnet is called magnetic force. These are the examples. Next, electrostatic force. Force exerted by a charged body on another charged body is called electrostatic force. Did you see this example?
Yes, Mrs.
We'll see the video later. Next one is gravitational force. We all know that every object in the universe is attracted by Earth. Every object in the universe is attracted by Earth. So that attractive force is called gravitational force. Attractive force exerting between two objects is called gravitational force. Who found the gravity? Yes, Sir Isaac Newton found the gravity. That's why the unit of force it is known as Newton. So we are representing the unit of force as capital N. Clear? Clear? Then we can go for a review. What is contact and non-contact force? We can learn from this video.
Contact forces and non-contact forces. The names themselves explain what they are, don't they? A contact force is a force applied on an object by touching it.
This is called a contact force. What do you say? Contact or non-contact? Let us see.
Well,
Yes.
muscular force, contact force, pulls the fish out of the water. In this case, the contact with the fish is with the help of the rope.
So what are the two types of contact force? Muscular force and frictional force. Which type of force is here? Non-contact. Let us check. Yes, it is the non-contact force and this is the gravitational
Non-contact
force.
force keeps the Earth in its orbit.
Here.
Contact.
Contact force.
Well done. The muscular force that sets the coin in motion, the push of the wooden frame that changes the direction of the coin's movement, and the frictional force on the surface of the board that stops the coin's movement are contact forces.
So these are the contact force. Here you can see how the contact force is acting. The frictional force is acting here, muscular force is acting here. So both type of contact forces are acting on this carabiner. Is it? Contact force. Is it?
Well done.
Yes.
The muscular force, a contact force applied on the pedal, keeps the bicycle moving. Well done. The contact force applied by the bow on the strings of the violin sets them vibrating to produce sound.
So here we are using muscular force on this object. So this is the contact force. So I hope you understand what is force and different types of force, how we are applying force on the object, and what kind of changes are made by a force. What kind of changes are made by a force? Force can change the state of rest, force can change state of motion, then size, shape and direction. And next one, the
Pressure of solids and liquids. Pressure will increase when the area on which the force is applied decreases. Liquids and gases exert pressure equally in all directions. The pressure of liquids will increase with depth. When we use our hand to press down on a book that's on a table, we are applying pressure to it. Pressure is the force that acts on a unit area. It can be calculated using the equation P is equal to F by A, where P is the pressure, F is the force, and A is the area on which the force is acting. In the SI system, the unit of pressure is the Pascal, PA, which is pressure applied by a force of 1 Newton on 1 square meter, N by M squared. Solids, liquids and gases are all capable of exerting pressure. Solids such as our book on the table will exert pressure only in a downward direction because of the weight. Heavier solids such as a much larger book will exert more pressure. Pressure will increase when the area on which the force is applied decreases. When we cut an apple with a knife, the sharp edge will make contact with a very narrow surface area. This will create an increase in force, causing the knife to cut the apple very easily. But if we flip the knife over and use the same amount of force to try and cut it with the broader, dull side, the larger area of contact will spread out and reduce the pressure, making it more difficult to cut the apple. Liquids exert pressure equally in all directions. Let's take a polythene bag and punch several pinholes on it and then fill it with water. You'll see the water spray from all of the holes, proving that water.
Here you can see in this cover, the pressure is exerting all part of the body equally. And one more case is pressure is increases with whenever the height increases, and pressure is decreases with whenever height decreases. That means it is directly proportional. Pressure with height and depth are directly proportional. Directly proportional means when height increases, pressure increases. When depth increases, pressure increases. Is it? So that kind of relation is called a directly proportional relation. So in this body, the pressure is exerting, the liquid pressure is exerting all part of the body equally. Okay, then the unit of pressure is Pascal. The unit of pressure is Pascal.
Water exerts pressure in all directions. The pressure exerted by liquids will increase with depth. Take an empty plastic soda bottle. Using a sharp nail, pierce small holes on it, one below the other. Fill the bottle with water. We can see the water spouting from all holes. Because the pressure of liquids will increase with depth, the water will shoot further from the lowermost hole. The speed of...
See, here you can see that the pressure is high in the lower part of the body. Why? Because the pressure is increases when the depth increases. Pressure is increases when the depth increases. That's why from this hole the water is moving more. Water is coming out more from that
will
hole.
decrease in the upper holes with the slowest speed from the uppermost hole. Summary. Pressure is the force acting on a unit area. Pressure will increase when the area on which the force is applied decreases. Liquids exert pressure equally in all directions. The pressure of liquids will increase with depth.
So I hope you understand that. Today we learned force and pressure. So you learn what is pressure. What do you mean by pressure?
The force which acts on the solids, liquids and gases.
That means per unit area. Force acting in a unit area is called pressure. Pressure, for finding pressure there will be an equation, that is pressure is equal to force by area. So that equation is showing the relation of pressure and force. Clear? So So whenever the depth increases, pressure will increases. Whenever the height increases, pressure will increases. So force, we already learned the force also. Different types of force. What are the two types of force? Okay. So what are the example for contact force?
Muscular force and frictional force.
Yes, very good. Muscular force and frictional force. And two example for non-contact force.